Hello, dear students. I am Dr. Kapil Chaturvedi, Associate Professor, Department of Computer Science and Engineering, Saga Institute of Research and Technology, Sage Group, Bhopal. In this video, we will cover the different topics of our subject: data analytics, inferential statistics, mean, median, mode, range, and at last we will discuss the variance. So, as our subject, we'll have to understand what is data analytics. So data analytics is a mechanism in which we apply multiple processes or big data or huge data, which is stored in data centers. We will have to apply expert mechanism on the data to find the knowledge or to discover knowledge. So we know very well that to mine knowledge, we apply multiple algorithms. But the ultimate goal of this whole mechanism is to find out the conclusion. So to understand the term statistical inference, we'll have to understand the meaning of the two terms, statistical and inference. So the statistical, it means we'll have to apply some mathematical formulas or mathematical uh, approaches on the data to find the conclusion, to drive conclusion. So the term inference, it means conclusion. So the statistical inference, it means by applying different statistical methods, formulas, we will drive a conclusion. So that mechanism will be known as statistical inference. And in this diagram, we can see that here we have a population, and uh, we are uh, taking one sample from that population. So population, it means the whole data set. Population, it means the whole data set. We are selecting one sample data from that uh, data set, and we assume some hypothesis and apply some approaches on the data and draw the conclusion on which is based on that data. So on the basis of that data, we can predict something. So that simple diagram says that we will have to apply the expert mechanism on the huge amount of data to drive conclusion. So that mechanism will be known as statistical inference. In another terms, to more understand the term statistical inference, here we are representing the same thing which was discussed in the last diagram. Here, population, we are selecting sample from the population, and we drive, we apply the statistical methods of the data. What kind on what data? Sample data. So we first of all we select the sample data, and we apply the statistical mechanism and drive the inference. So we want to learn about population parameters using statistical calculated in the sample. So that both of the things say that you will have to draw a conclusion by applying statistical methods. And here are one official definition of a statistical, formal definition of a statistical inference is that is, statistical inference is the act of generalizing from a sample to a population with calculated degree of certainty. So here we'll have to find the conclusion and try to know that what is the certainty of uh, event. Another example is here that one person is finding out of fetching, trying to fetch the knowledge, or trying to fetch some knowledge from book. For example, if I ask you that why we read books, so the answer would be we read book to gain knowledge. So here we are saying that uh, we read the book and make our assumption something about that content which we are reading, and draw a conclusion on the basis of that textual content. So this is also inference. So formally, the inference is a five-step uh, procedure. Or we can say that we'll have to follow basically, fundamentally, five steps to draw conclusion. What kind of steps we have to follow? So first step will be read or view the text. So if we on if we have to fetch some knowledge from huge data set or simple data set, first of all we will have to read that or view that data set. Then read the question. Read the question, it means what kind of knowledge we will have to find, what kind of knowledge we will have to extract. And the third point is list relevant details. We'll have to make a list what kind of knowledge we'll have to find out. Put details together. Then we'll have to put all the things which we gather at the time of analysis, what kind of knowledge we'll have to discover, or what kind of points we have to focus, what kind of text or content we read. Put these all things on samples, and by analyzing that whole data, whole information, we our result, determine our result, what we have try to fetch the knowledge. By putting these things or to analyze these things, we fetch the knowledge. But here something is very important. We have to whenever we have to find the conclusion, whenever we have to drive conclusion, we must have to know the background knowledge of that particular area. We will have to conclude something about share market, then you have to know very well what is share market, what is their working procedure, how the rate of shares will increase and when the rate of shares will decrease. So the background knowledge should must when we have to draw a conclusion from text or our data. So we read the data, apply our background knowledge, and draw a conclusion, which is our inference. So this is all about inference. Now, the another diagram, inferential equation. If I say that you will have to represent the inference in an equation, then what you will, how will represent that? What I read, what I know, and what I infer. So what I read, it means what I am reading, what I am viewing, and what I know about that. We apply our knowledge on the data and draw a conclusion. And the conclusion is known as inference. So inference is nothing. Inference is the conclusion. And if we are driving that conclusion by applying statistical methods, then the terminology is known as statistical inference. Now, uh, we are saying again and again, we will have to apply statistical methods. So what kind of statistical methods will have to apply to draw the conclusion? So very first term is mean, second term is median, third term is mode, and fourth term is range. So the mean it means we'll have to first of all we'll have to find the sum of all numbers. We'll have to find the sum of all numbers and divide by number of items. Divide by number of items. Here we are seeing that 9 plus 3 plus 1 plus 8 plus 3 plus 6 equals to 30. And we divide that number by 6 because there are 6 numbers, 1, 2, 3, 4, 5, 6. So to find mean, we'll have to find the sum of all numbers and divide the number of numbers or number of items. So we got the mean value. Another is median. So the median is order the set of numbers. The median is the middle number. So first of all, we will have to arrange all the numbers in sorting order, and we try to find out the middle value. But let's suppose the in series will have even numbers, then we cannot find out the middle number. Then what will be the mean value? We'll select two numbers in between the range, it between the list, and divide by 2. In this example, we find out the sum of these two middle values. 6 plus 3 equals to 9, divided by 2 equals to 4.5. So this is median. And what is mode? Mode, it means most common number or repeated number which is coming in the series repeatedly, or the frequent number which is coming series in again and again. So mode, if we have to find out the mode in the series 9, 3, 1, 8, 3, 6. So we are seeing that 3 arrive two times. 3 occurs two times in the series. So we will say mode will be 3 of the series. And what is range? Range, it means difference between the highest number and the lowest number. So here in the series, the highest number is 9 and lowest number is 1. So we will find out 9 minus 1 equal 8. So 8 is the range of the series. Range, it means what is the scale of this that series. Okay. Then the same thing we can understand by the diagram where we are calculating mean by find out the sum of these numbers and divide the number of items. We will easily find out the result. Median, it means we'll have to find out the center value. If we have the even number series, then we'll have to find out the sum of middle two numbers and divide by 2, and that number will be the median. Mode, it means the repeated number which is repeatedly arrive in the series. If we uh, have a series where uh, two numbers are arriving multiple times with the same frequency, then we will say that two numbers will both of the numbers are the mode of this series. Here we are seeing that two come in this series two times and 5 occurs two times. So the 2 and 5 will be the mode. And in case of range, what we have to do, we'll have to do nothing extraordinary. We'll have to uh, find out the difference between highest number and the lowest number, and we got the number, and that number will be the range. Now we are going on some advanced level. Now we'll have to learn what is variance, because variance is very important topic in the first unit. uh, we'll have to learn a topic, we'll have to discuss a topic, ANOVA. And the meaning of ANOVA is that analysis of variance. So to understand ANOVA, first of all, we will have to understand the variance. How we'll calculate the variance of given data, and what is the meaning of variance. Okay. So the variance defined as the average of the squared difference from the mean. Actually, that definition is not very clear. So to understand that terminology, I'm taking one example. That is the best example to understand the variance. Okay. Here we are taking one example. In this number of pairs are on my graph. And first of all, I am finding out the heights of these pets. So I measure the heights of that pet. So that pet height represent that arrow, and the height of that pet will be represented by that arrow. So similarly, firstly I am finding out the height of that pets. No, what we have to do? No. First of all, I am calculating the mean value. Mean value, it means the height of all the pets, the sum of height of all the pets will be divided by number of pets. So we got number 394. So 394 is our mean. 394 is our mean value. So we are doing nothing extraordinary in this diagram. Our data is the height of that pets, and we are finding out the mean height. so that so we find out the sum of all heights and divide by the number of beds. We got number 394, which is our mean. Now, something is very important to understand in this example. Now, very seriously, have a look. Uh, so our mean is our mean is in previous size we calculate the mean to 394. So what we have to do? We have to do we have to find out the differences between with mean. So here we are finding out the differences with mean. So the pad which has some height on this position, firstly we find out the difference between mean height and that height and put the respective number of respective place. So we are proceeding from here. So that pet's height is 600, and we are finding out the difference. It means the height is 600 and the mean is 394. So what we have to do? 600 minus 394. 600 minus 394 equals to be 206. Okay. On the next position, here the height is 470 and our mean value is 394. So 470 minus 394, we got a number 76. Similarly, we will find out the difference of that, and that. Okay. And by finding out the difference, we'll have to calculate the square values of that differences. We will find out the square of 206, square of 76, square of minus 224, square of 36, square of 94. And by solving that, we receive a number 108520, and we divide that number by number of beds, which is 5, and we got a number 21704. This is our variance. And then if we have to calculate the standard deviation, then we are nothing to do, uh, and we don't have to apply much efforts to calculate the standard deviation through variance. We'll just have to find out the square root of variance. Square root of variance will be the standard deviation. So here we are applying the square root of 21704. We got a number 147, which will be our standard deviation. So this is the mechanism of finding out mean, median, mode, variance, and standard deviation. So this is the simple example to remember the meaning of variance. And the next topic is ANOVA. So the ANOVA, it means analysis of variance. Analysis of variance is a variability ratio. So we are not going on the term variability ratio. We are just keeping in mind analysis of variance. And what is variance? We calculate the variance in the last numerical example. Okay. So in this example, in this diagram, we are saying that we have some variance that that curve shows different variances, and what we have to do, we'll have to analyze that variances, and that analysis will be known as ANOVA. Okay, so first of all we have to understand what is ANOVA and from where the theory comes. So in 20th century, there were in statistical mathematics to compare two groups. Mathematicians apply different mechanisms to compare two groups, like z-test method or t-test method. So the utilization of that method is to find out the differences between, or to compare two groups. Okay. Then Ronald Fisher was a scientist who discovered the concept of ANOVA. ANOVA is also known as Fisher test. Why? What is the extraordinary in ANOVA? So in t-test, we compare only two groups. But in case of ANOVA, we can compare multiple groups. We can compare or analyze multiple groups. So that theory says the same terminology, the T and Z test method developed in the 20th century were used for statistical analysis until 1918, when Ronald Fisher created the analysis of variance method, ANOVA. ANOVA is also called the Fisher analysis of variance, and it is the extension of the T and Z test. The term became well known in 1925 after appearing in Fisher book, Statical Methods for Research Workers. It was employed in experimental psychology and later expanded to subjects that were more complex. So that theory says that in 20th century, t-test was there to compare two groups. What Ronald Fisher developed one more advanced mechanism which is more capable than T and Z test, also known as ANOVA test, also known as Fisher test, Fisher analysis test, which is capable to compare multiple groups. So, formally, analysis of variance is an analysis tool used in statistics that splits an object aggregate variability found inside a data set into two parts. So, to uh, to analyze the variance values or to find out the ANOVA inside of data set, it means uh, actually we are working off that actual data. So what we have to do, so there are two parts, systematic factor, and next one is the random factor. Okay, first one is systematic factor and the next one is the random factor. So the meaning of systematic factor means the systematic factor have a statistical influence on the given data set. And what is the meaning of random factor? Random factor do not analysts use the ANOVA test to determine the influence that independent variable have on the dependent variable in the regression study. Now, the systematic factor have a statistical influence on the given data set. But in case of random factor, do not analysts use the ANOVA test to determine the influence that independent variables have on the dependent variable in a regression study. It means directly we can say that in systematic factor, we use the internal variable which will affect the analysis procedure, but in case of random factor, we will use the regression analysis. It means the concept of regression line to analysis the data. So the ANOVA formula says that analysis of variance or ANOVA is a strong statistical technique that is used to show the difference between two or more mean or components through significant test. As we discuss in the diagram, is we discuss in the numerical, where we are analysis the variance value. It also shows us a way to make multiple comparisons of the several populations mean. We also discussed that point in the fundamental discussion of ANOVA, in which we discuss the concept of T and Z test, uh, which is used to analyze or compare two groups. But in case of ANOVA, we can compare multiple or several groups or the populations. Population, it means real data sets. The ANOVA test is performed by comparing two types of variation. the variation between the sample mean as well as the variation within each of the samples. So, if we are discussing about, we will have to analyze the variance. It means we will focus on the single variance value and we will focus on the mean value of particular variance as well. We'll also focus the mean value of different variances, because we'll have to compare multiple data sets. We are saying that we are making the comparison of multiple populations. So if we are discussing about multiple populations, the number of variations, that will focus on the internal variance mean, also that will focus on the different variances mean, variance mean. So this is all about the statistical inference, in which we discuss the concept and the formulas of mean, median, mode, and uh, range also. And then we calculate the variance by taking one example, real world example, and thereafter we learn how to find the standard deviation using variance, and thereafter we discuss the concept of ANOVA, fundamental of ANOVA, and the meaning of ANOVA. So this is all about today's lecture. In the next lecture, uh, we will discuss the big data and data science fundamentals. Thank you.